everyone. So last time I tried to create a video where I solved a lead code problem using test-driven development, and I started with a very easy problem, and I learned something that for an easy problem, test-driven development does work in an interview setting, sort of. But I wanted to take that a bit further and get a slightly more concrete proof that it will actually work with the problems that you are likely to find in interviews generally. So I found out there's a list called Blind 75. It's a very popular list out there apparently, and that is something that people use to prepare for interviews using lead code. So thought it might be a good idea to solve that list using test-driven development. And that's what I'm going to do in this series of videos. So again, our assumption will be the same. We'll try to solve all these problems in like for 20 to 45 minutes, as it generally is in an interview. So yeah, and we'll see where we go from there. Uh, let's get started. So uh, this is the blind 75 list. Uh, Let me open up my IDE. Create a package. Okay, we'll start from the top and work our way down the list. So today we're going to solve this problem called TwoSum. Okay, let me check what the time is. It's 8:25. Hopefully by 9 a.m. I have this solved using test-driven development. Uh, that's 35 minutes starting now. And if that's not the case, we'll see what we could have done better. Given an array of integer nums and an integer target, return indices of the two number such that they add up to the target. Okay. You may assume that each input would have exactly one solution. Okay. And you may not use the same element twice. Exactly one solution. So what is our input? List of integers and a target. Returning the two numbers that they add up to. Okay. So let's take an example. So for 2, 7, 11, and 15, target is 9, then 2 and 7 are your is the pair. And we need exactly two numbers which sum up to the target. Now, just thinking through the problem, generally this seems like it would be easier to do if the array is sorted. And then what we could do is like a binary search where we have instead of searching for one element, we are searching for a pair. And yeah, and it's and if the array is sorted, then the left we know the order in which where we need to move our window based on if the target is less than or greater than the current sum of the two indexes, right? So that is probably the approach I would take for the solution. Uh, okay, but the thing with CDD is you don't you start with a failing test, and, and yeah, let's not think too much ahead. So class do some. So first test I can think of, array is empty, input is empty array. So what should it return? Okay, you may assume that each input would have exactly one solution. So if you're looking for, if you're assuming that each input would have exactly one solution, then we don't need to worry about this. This is not a valid test case, so I would not write it. So what I need is an input, simplest input with exactly one solution that I can think of. Okay, so to get to a target using a pair, the least number of input values I need in an array is two. So array has two integers. Let's say target matches their sum should. What are we returning, by the way? We are returning an array. Okay, return 0 and 1. 0, comma 1. So this is my first test case. To solve this, I need a class called TwoSum. I don't have it. I will go ahead and create a class called TwoSum. TwoSum, TwoSum equals new TwoSum. TwoSum needs, yeah, find. And when we are initializing it, we can, so we need an input. Okay, so input first is input. First input is an array of integers called nums. New int 1 comma 1. That's our array. Second input is the target, which in this case should be 2. And I will pass these two to my TwoNums class. This is okay, doesn't take that. I'll create a constructor private nums private target. And the constructor, okay, TwoSum equals new TwoSum dot get matching indexes. So this should return an array. This method is not there, so I'll go ahead and add it here. It returns an array of integers. Assertion. First assertion is Indices should not be null. It says you can return the answer in any order, so uh, it doesn't necessarily have to be 0 and 1. It can be 1 comma 0 as well. So how do we compare that? Let's create a uh, set assert true, assert. So our assertion would be assert true set dot of 0 comma 1 contains indices of 0, and the second assertion would be the same set would also contain indices of 1. So this is my first test. Need to make it pass. First I need to make it fail. How much time will be? Okay. Okay. So we need to implement this method. Get matching indices. So I will only care about my making my current UT pass. Um, right. So the simplest thing is if nums dot length equals 2 and nums 0 plus nums 1 equals target, return new int. This solution is obviously wrong, but I do not care. Uh, so um, I'm only solving my test cases. Test case. Uh, it has passed, so I need something more sophisticated. Uh, let's write the next test case. Void. So let's make it 3. And since we don't want 0 and 1 to be the answer, let's say in this case, target matches the sum of second and third. Should return 1 comma 2. Mhm. Copy and paste this. So my array is 1, 4, 3, and target is 7 because we want this to be the answer. Set of 1 comma 2, 1 comma 2. Okay, now we do need to solve this problem. First approach is uh, brute force. Right. By the way, just so I'm not missing anything, this doesn't say anything about the input being sorted, right? return this is up to number so that they add up to the target. Okay, so two things. Uh, it doesn't say that the input is sorted, and we have to return the original indexes, which means if we sort the array in place, those indexes would be lost. So sorting and then doing binary search kind of thing is out. Sorting anyway would take order of log n, and we don't want that. So sorry, n log n. Probably don't want that. So the other approach I can think of for this is basically a hash map kind of approach where the hash function is basically the sum function. So the hash of a number would be target minus the number. Let me think. Yeah, so 4 and 3 match. Uh, the hash, yeah. So for f of 4, I should get 3, and f of 3 should be 4. And if that is already there, so I would, so let's say there is a set which contains uh, for which we calculate hash and okay, uh, let's not try to do much. Uh, let's just make this test pass using whatever I thought in my head. It's easier. Uh, okay, so yeah, so what I would do is let me get rid of this solution because it's not going to work anymore. Uh, if so, let's say should I say map integer hash set? What does hash table? It makes okay. Okay. What I'm going to do is okay, yeah. So for 4, I'll calculate its hash. It's 3. Does the set already contain the hash of 4? If not, I will add 4 to the set. If it does, I'll return 4, the index of 4 and the index of 3. So I know the index of 3, but for 4 because that's where I am currently. For 3, I will need to save the index so that I don't have to go look it back, and then that's actually I can search for its order one. Okay, Yeah, I don't need to save the index either. Fine. Okay. So what I'm thinking is, okay, I'll have a set of integers. Uh, hash new for I 0 I less than nums I plus plus if so hash function hash set dot contains target minus nums of I return new int I comma index of index of target minus nums I. We'll implement this here for private method. Private index of int I dot int I less than length plus plus if val equals nums I return I minus 1 and throw index of right get matching indexes. Okay, let's try running our test now. I haven't got a chance to think the whole thing through yet, but we'll see where we have gone wrong. Runtime exception. Okay. Class eat it. Set contains target. Oh, I have not added anything in asset. Okay. Else uh, asset dot add nums I. Oh my god. Oh, it passed. Cool. Let me see if my first test still passes. It does. So all my tests pass. I only have two tests till now. Let's try using lead codes test cases uh, for a start. Lead code test one. 2, 7, 11, 15. 2, 7, 11, 15. What's the time? 8:50. Okay. I think we're 25 minutes in and we have solved the problem. We're just uh, verifying it. And the index should be 0, 1. The first test passes. 3 to 4. Test 2, 3, 2, 4. Target is 6. 1, 2, 1, 2. Second test passes. 3, 3. Test 3, 0, 1, 0, 1. Okay, so far so good. Let's try submitting this as a solution. We might have to make some changes here. So TwoSum class. TwoSum. And if it lets me change let me not actually undo the whole thing. Okay, what I will do is copy this in here and sorry, copy this in here. TwoSum, TwoSum equals new TwoSum nums, target return to TwoSum. Uh, how do I run this thing? Why is this not running? Okay. Oh, it's accepted. Okay, cool, awesome. Happy with that. So our target was 9, around 35 minutes. We did it in less than 30 minutes. Not bad. So looks like so far so good. We'll continue this in our next problem next time, which is I guess longest substring with repeating character without repeating characters. So watch out for the next video for that solution. Uh, bye. Thank you.